So I will touch upon the Kubernetes architecture on a high level, right? So in Kubernetes, what you have is you have the control plane, right? And you have the workers. And in control plane, you have these many components: the etcd cluster, the controller manager, the scheduler, and the kube API server. And on each of the worker node, what you have is kube proxy for managing the networks, kubelet for managing the nodes, and the container runtime for running the containers, right? So these are the very high level components which are available in Kubernetes architecture. But Kubernetes needs to store the entire cluster state, right? For example, pods, nodes, config maps, secrets, replica sets, service definitions. So it has to maintain or store the entire cluster information. What pods are healthy, what nodes are healthy, right? Which are the environment variables. So all this information has to be maintained. Now I will be explaining this with a real example. Now let's see that how etcd is being used in Kubernetes effectively. So I have taken a very simple example. So generally you have the YAML files, and in those YAML files you define all the description, what you need, what kind of object you need in Kubernetes. So for example, this is the pod YAML file, right? So to create the resources into the Kubernetes cluster, what you need to do is you need to do this command, the kubectl. The kubectl is the command line, and the apply is you want to apply the operations on this file. That is, the file is pod.yaml, right? So that's how you would be writing this Kubernetes command. Now what would be happening in this case? Now whenever you are sending this command, first of all it goes to the API server. Then API server writes this request to the etcd, and etcd appends into its wall file, as I mentioned, similar to here, right? So it appends to its wall file, then replicates to its quorums, commits, stores in WallDB, and then only it would return the response back to the API server, and then the API server would be returning the success to the client. In Kubernetes, everything to etcd is happening via the API server. Only the API server can do operations on etcd cluster, not the controller manager, not the scheduler, not the worker nodes, nothing. So it is a single responsibility. Only and only the API server can access the etcd cluster. Now why this design is such a way? It is because of security issues, because etcd is a critical database. Only the API server has this credentials, because you can enforce security policies onto the etcd cluster. You can apply role-based access control onto this API server level, so that only and only the API server can access the etcd cluster, not the any other component. So if everyone start using or accessing etcd cluster, so there is no centralized authentication, because you have to manage so many things in that case. So this design is taken considering the security principles. Now let's see how Kubernetes creates this key in etcd, right? So if you see over here, the default is the namespace and the pod name is the nginx. So if you see the key, this is the kind of definition, right? Registry pods, and this is the namespace, and this is the pod name. Now if you want to find out all the pods in the default namespace, so you can easily do that with the prefix option, as I described earlier, right? So that is the reason how the key has been created. And value could be the JSON. So for example, the JSON could be the kind of pod, the version, the metadata name, right? The whole specification, whether it is running or not, what is the pod IP. So it is the kind of value which would be stored into this etcd. Now the value could be JSON, could be text, could be binary, could be anything, but in reality the value in etcd is always stored in binary format, that is the protobuf format. For efficiency, etcd does not understand Kubernetes objects. What it sees is, it sees the key as bytes, and also it sees the value as bytes. So that's all it knows. Now let me erase this. So similar to pod, what you would be having, what kind of different objects you would be having? You would be having the nodes. So in that case, what would be the key in the etcd? That would be the registry nodes node 1, and you can have all the information, whether it is healthy, running, or whatever the kind of information you want to maintain. Now similar to node, you have the deployments. So for that you can have the registry deployments. Now you have the namespaces, you have the config maps. So similar to that, you can have this configuration, this key created, right? The registry config map, and you can have the namespace. that in this namespace, this is the config maps created. So you can store all the Kubernetes configuration in etcd cluster like this, and Kubernetes exactly does the same. But how does etcd knows about the worker node status, right? So etcd cluster here, but how does it know whether the worker is healthy or not running? How it knows that? So what is happening here is etcd does not know anything by itself. It does not monitor the nodes. The responsibility chain is the kubelet. So if you see, on each of the worker you have the kubelet. So what would be happening is kubelet would be periodically sending the heartbeat to this API server, and API server would be writing to this etcd cluster. As I mentioned, if this heartbeat or update not received after, let's say, 40 seconds, so what would be happening is the key for this worker would be deleted automatically. So for example, this would be the key, the registry nodes node 1, right? So if this key has not been updated since last 40 seconds, the etcd cluster would be kind of removing this key automatically, and that is when it would notify the API server, and API server would be streaming this information to this scheduler or controller manager, and that is when the controller manager would come to know that, okay, this node is unhealthy. So the workflow would be, the worker node is there, it uses the kubelet to send the heartbeat to API server. API server writes into this etcd cluster. etcd persists into its wall and replicates to its quorum, stores into this bolt db, and returns back to the API server. And the API server then streams this to scheduler or the controller based on the kind of request it is. If it is a node, then it would send to the controller. If it is a pod or any kind of different services, it would be sending this stream to the scheduler, and then the scheduler would be spinning up the different pod, right? So via the API server, so it would be sending the request to the API server to instantiate the pod or the other things. Then the API server would be kind of again doing the right operation into this etcd cluster and creating the pods or any other object in the Kubernetes cluster, right? So in this case, if you see, etcd stores the complete cluster state information. So we can use etcd to store all the cluster information, what all nodes are healthy, what all pods are healthy, what is the status, what are the heartbeats, what are the configuration. So all kind of information we can store in etcd cluster to maintain our cluster healthy and running. So that's all from this video. Please do like, subscribe and share my channel with your teammates and other friends. So in the next video, we will do the practical demonstration of the etcd cluster. We will get our hands dirty by playing with etcd cluster. So stay tuned. Thanks for watching. See you in the next video.